Okay, so we're going to pull some things together that we've kind of talked about with sine and cosine to talk about tangent a little bit. So in a few minutes, we're going to find some values for our tangent ratios given some angle measures, but let's just talk about tangent itself and how it relates back to sine and cosine. So if you remember, the definition of sine, right, we've said was opposite over hypotenuse. But if we're on our unit circle, which we are, and the radius is 1, then that means the hypotenuse of all of these triangles that I create is always going to be 1, right? The radius is 1, so the hypotenuse of all these triangles will be 1. So if I have a unit circle with a radius of 1, then the sine is equal to the opposite, and I don't have to worry about the hypotenuse. Okay, and then we also discovered that that opposite of this reference angle, that opposite side, is also the y-coordinate of the point right here. So the y-coordinate is also important to us when we're talking about the sine. So the same can be true about the cosine. So my definition of cosine from a couple weeks ago and back in geometry is the adjacent over the hypotenuse. But, right, if the radius is 1, that means my hypotenuse is 1, and I can just say I'm worried about the adjacent side, which happens to be the x-coordinate of that point on the unit circle where my angle in the terminal side of my angle in standard position hits the unit circle. So if that's the case, then now let's talk about the definition of tangent for a minute. So the definition of tangent from geometry and a couple weeks ago was opposite over the adjacent. But if I now have a unit circle, the opposite is the sine and the adjacent is the cosine, so I've got a new definition for tangent, which is sine over cosine of that angle. And so we're going to use that as we talk through finding the tangents on unit circles. So let's talk about this angle now. Let's be specific. So negative 5 pi over 6. If you want to change this to degrees to make it a little bit easier to manage, again, this pi in radians is the same as 180 degrees. And 180 degrees divided by 6 is 30 times negative 5 is, our theta is negative 150 degrees. And you can find that on your unit circle that I gave you last week. Right? We know that positive 5 pi over 6 is positive 150. So negative, if I go in the opposite direction, is going to be over here in this quadrant 3. So I'm going to just draw a little. That's going to be the terminal side of my negative 5 pi over 6 or negative 150 degree angle. Right? That's negative direction. And so the negative 150 degrees, this is negative 180. I know that reference angle is 30 degrees. There's a 30 degree difference between there. So if I create my right triangle, and I know my radius or hypotenuse is 1, then I can use my 30, 60, 90 special right triangle to find these other measures. So the short leg is this one. It's going to be opposite the 30 degree angle. The short leg is always half the hypotenuse. So I have, and we're going to do that in blue. I've been trying to keep our opposites in blue. Is going to be 1/2. So that means the sine of this particular angle is 1/2. Now, is it positive or is it negative? Well, because I'm in quadrant 3, let's use a different color, quadrant 3, Okay, notice that from the origin I have to head down to get to this point, so it's really a negative 1/2 value. This is a negative 1/2 sign. Let's see, negative 1/2. And then my cosine is this adjacent side. Well, this angle way down here is 60 degrees. That makes this green side my long leg. 1/2 times the square root of 3 is going to be square root of 3 over 2 is going to be the long leg of this right triangle. It's the horizontal measurement, so that's my cosine, right? Because it's adjacent to my reference angle. It's also the x-coordinate. Now, is it positive or is it negative? Well, again, here's my origin. I'm headed to the left. This is going to have a negative value, so my cosine is going to be negative square root of 3 over 2. Let me put my negative right here with this 1/2 as well. So my tangent we've now defined as the opposite over the adjacent, right? That's from geometry, but that's the same in a unit circle as sine over cosine. So my tangent, the sine is negative 1/2 over, the cosine is negative square root of 3 over 2. So when you take a fraction and divide by another fraction, let's first talk about the fact that a negative divided by a negative is going to be a positive. So these are going to turn to positives. And then the fraction 1/2 divided by this fraction means I can multiply by the reciprocal of that denominator. The 2's are going to cancel. I get 1 over square root of 3. And then we remember we're not allowed to leave an irrational number in the denominator. And so we're going to multiply by square root of 3 over square root of 3. And the answer is 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is square root of 9, which is a nice whole 3. And it's positive because both the sine and cosine were negative. Negative divided by negative is positive. So the tangent of negative 5 pi over 6 is positive square root of 3 over 3. Let's do that again. Talk about tangents some more. Let's see, going all the way up here. Okay, so again, we've now defined the tangent of an angle as the sine over the cosine. If it's a unit circle, that's the same as the y-coordinate over the x-coordinate. Okay, so let's find out where 3 pi is. So we can multiply 3 with 180 degrees to find out where that is. We can think of this as 0, and all the way around my circle once will get me to 2 pi, and then a third pi, right, because we have 3 pi's, is going to be another over here. So 3 pi is actually has a terminal side that's on my negative x-axis, negative x-axis here. And if I'm talking about a unit circle around there, then it's going to have a point. That unit circle is going to go through the point that is from the origin -1 in my x direction and then 0 in my y direction. So that's going to be the ordered pair of where my unit circle intersects this terminal side. So we've said that the cosine is the x-coordinate. That's going to be -1. Let's write cosine. And the sine is the y-coordinate. That's going to be 0. So the tangent of 3 pi is the y-coordinate 0 divided by the cosine's coordinate of -1, and 0 divided by anything is 0, and that's the tangent of 3 pi has a value of 0. So even though I couldn't create a right triangle with this terminal side, I knew that the x-coordinate was the same as my cosine and the y-coordinate's the same as my sine, as long as we're talking about a unit circle.